Good morning, sir. Myself Muhammad Asif from CSC D section, and my today CAA assignment 2 topic is types of polarization. Let's move on another slide, sir. This is Introduction to polarization. Polarization refers to the separation of charge within a material. It plays a crucial role in the dielectric properties of insulators and dielectrics. Understanding different types of polarization helps in material selection for various applications. Polarizations and different types. Let's move on definition, sir. When an electric field is applied to a dielectric material, the separation of charge carriers takes place that includes dipoles throughout the material. This process produces dipole by influence of an electric field is called dielectric polarization. There are different types of polarizations. There are electronic polarization, ionic polarization, orientation polarization, space charge polarization. Let us, dis- Let us discuss one by one, sir. Electronic polarization. When electric field is applied on a dielectric material, then all the positive nuclei of atoms move in field direction, and all the negative electron clouds of atoms move in opposite direction. Hence, dipole will be formed. This phenomena is known as electronic polarization. It means the dipole of a positively charged nucleus and the electrons of an atom in opposite directions and directions on applications of electric field is called electronic polarization. Mechanism of polarization. The application of an electric field causes dis- distortion in the electron cloud. Electrons are displayed slightly from their equilibrium position but remain bound to their nucleus. The resulting dipole is contribute to the overall polarization of the material. Here, this picture refers the positive nucleus moves one side and the total negative electrons moves another side. Sir. Applications of electron polarization. Electronic polarization is a vital in design of capacitors and insulators. It impacts the frequency response of materials used in high frequency applications. Understanding the polarization helps improving the efficiency of electronic devices. Let's move on ionic polarization. Ionic polarization occurs in materials with ionic bonds where ions can move slightly under a electric field. This movement leads to the formation of including dipoles in the materials. Ionic polarization is significant in the context of ionic crystals and electrolytes. It is due to displacement of anions and cations in opposite direction and occur ionic materials when placed in electric field. Mechanism of ionic polarization. When an electric field is applied, cations and anions in a ionic lattice shifts slightly from their position. The this shift creates induced dipole within the material due to the relative displacement and positive and negative ions. The polarization persists as long as the electric field is applied and influenced by the temperature. This picture refers the clear detailed explanation about the ionic polarization. Here, this is the distance between displacement between two anions and cations. Let us example NaCl. Na plus is anion and Cl minus is cation. Applications of ionic polarization. Ionic polarization is a crucial in understanding the behavior of ionic conductors. It is important in the design of batteries and fuel cells where ionic movement is key. Key knowledge of ionic polarization assists in optimizing the performance of dielectric materials. Now we discuss orientation polarization. It is also called as dipolar polarization. Orientation polarization occurs in materials with permanent dipoles such as polar molecules. These dipoles align within a electric field, contributing to overall polarization. It is temperature dependent as thermal motion can disturbance dipole alignment. Mechanism of orientation polarization. These pictures refer the clear detailed explanation about orientation polarization. That means dipolar polarization. In presence of an electric field, the permanent dipole experiences torque. Here, the permanent dipole experiences torque aligning themselves with the field. The alignment leads to increase the material's dipole moment. The effect is more produced and at lower temperatures with thermal uh, annihilation is reduced. Applications. Orientation polarization play key role in properties of liquid crystals used in displays. It is essential for understanding dielectric materials in capacitors. The principle of orientation polarization helps in designing materials for sensor and actuators. This is the final one. Space charge space charge polarization. It is also called interfacial polarization. The space charge polarization arises from the accumulation of charges at interferences or within the bulk of an dielectric. This polarization occurs when charge carriers, that is like ions and electrons, means ions or electrons or charge carriers, migrate under an electric field. It is particularly significant in heterogeneous materials and composites. Mechanism. As an electric field is applied, mobile charge carriers accumulate at boundaries, creating localizing electric fields. These accumulations can lead to significant increases in the effective dielectric constants. Space charge polarization is often observed in polymers and composite materials. Applications of space charge polarization. That means space charge polarization is a crucial in performance of polymer dielectrics and insulating materials. It is essential in understanding charge transport in semiconductor devices. This type of polarization also influences the behavior of capacitors under varying conditions. Summary. Understanding electronic ionic orientation and space charge polarization is vital for material science. Each type of polarization contributes uniquely to the dielectric properties of materials. Knowledge of this mechanism enables the development of advantageous electronic and electrical components. There is a detailed explanation about each type of polarization. Thank you, sir. This assignment was submitted by Muhammad Asif from CSC D section, Srinivas Ramanujan Institute of Technology, Autonomous. Thank you, sir.